Hello! Pull! Oh! Yeah! Woohoo!
Assalamualaikum. Hi, we will discuss about synthesis and characterization nickel 2 with DIPHENYLAMINE. This group consists of Siti AINAAISHAH binti AZIZAN, Siti HADIJAH binti MUSLIMUN, Siti Khadhijah binti NASIR, and lastly Siti NAZURAH binti NAZARUDDIN.
First is background of the experiment. Coordination chemistry is the fundamental chemistry of metal ions that receive electron pairs from their surroundings. Coordination compounds exhibit a wide range of color and coordination number of metal ions. Nickel is a transition metal that is abundant in nature as nickel 2 because it is more stable than nickel 0, nickel 1, nickel 3, and nickel 4. Each nickel 2 complex with specific ligand has different chemical and physical properties, making the investigation both interesting and challenging. Diphenylamine is an aniline derivative that plays an important role in the pharmaceutical industry. It has an electron lone pair as a donor site in the NH group, allowing it to function as a ligand. The objective of this experiment is to synthesize and characterize the formation and properties of nickel complexes with diphenylamine.
Procedure. In this experiment, there are a few apparatus and chemical used to synthesize nickel 2 with diphenylamine. Apparatus used in this synthesis is UV double Shimazu spectrophotometer, atomic absorption spectroscopy, KBR pellets, practice 21 Shimazu spectrophotometer, magnetic susceptibility balance, conductivity meter, glass rod, conical flask, filter paper, suction filtration, and the chemical used is methanol, diphenylamine, and methanolic solution of nickel nitrate hexahydrate. The step is, firstly, 10 ml of methanol was added into the conical flask, then 2.03 of diphenyl is added into the conical flask and stirred to dissolve it. After that, a drop wide of 10 ml methanolic solution of nickel nitrate hexahydrate was added dropwisely into the conical flask with the continuous stirring plus minus 3 hours. The solution was evaporated until the volume remained 10 ml. The green precipitate was formed after the 48 hours. Next, the precipitate was filtered off using the suction filtration and washed with the methanol. Lastly, the precipitate was dried out under the vacuum. The result obtained was recorded. For physical measurement, UV vis double beam Shimazu used for determination of spectra UV vis metal salt and metal complex in methanol solvent. Atomic absorption spectroscopy is to determine the nickel content in the complex. Plastic Shimazu spectrophotometer is to analyze the infrared spectra of ligand and complex as KBR pellets. Take susceptibility balance to measure the magnetic moment of the complex, and conductivity meter is to measure the molar conductivity.
Characterization of complex nickel 2 with diphenylamine. First, by UV visible spectrophotometer. The forming of the complex was indicated by shifting of maximum wavelength in UV spectra. The maximum wavelength absorbance shifted from 7 to 8 nanometer and 397 nanometer for nickel 2 nitrate hexahydrate towards smaller wavelength 7 to 4 nanometer and 396 nanometer in the nickel 2 diphenylamine complex. The shift of lambda max reveals the formation of the complexes between nickel 2 and diphenylamine. Nickel 2 diphenylamine absorbed red light and the complex appeared at green light about 7 to 4.50 nanometer. The complex was paramagnetic and had two peaks at maximum wavelength of UV absorption at 7 to 4 nanometer and 396 nanometer. Figure 4.1 shows the electronic spectra between A, which is nickel 2 nitrate hexahydrate, and B is nickel 2 diphenylamine complex in methanol. Second, atomic absorption spectroscopy (AAS) is a technique used to detect elements in either liquid or solid sample through the application of characteristic wavelength of electromagnetic radiation from a light source. Analysis of the nickel percentage in the complex by atomic absorption spectroscopy (AAS) show an empirical formula of the complex. The content of nickel in the nickel 2 diphenylamine complex measured by AAS presented a value of 5.92 plus minus 0.05%. The possibility of a complex formula can be obtained by comparing the nickel content of this measurement to the nickel content theoretically as shown in table 4.2. The third one is infrared spectroscopy. The infrared spectra of the complex reveal the characteristic bands of ligand function groups. The shifting towards the lower side in comparison of infrared spectra of nickel 2 complex and diphenylamine yield to the nitrogen atom of the secondary amine group coordinated on the nickel 2 center ion. The absorption band of the nitrate group which show that the nitrate ions coordinated on nickel 2 plus center ion also appear in infrared spectra. Lastly, electronic spectroscopy, an analytical technique to study the electronic structure and its dynamics in atoms and molecules. In general, an excitation source such as X-ray, electron or synchrotron radiation will eject an electron from an inertial orbital of an atom. The electronic spectra of the complex were recorded in methanol and exhibited two bands of DD transition. The transition occurs reveal that the nickel complex possess an octahedral geometry supported by their magnetic susceptibility values which is 2.9 to 3.3 Bohr-magneton. The structure of the complex is suggested as shown in figure 4.3 based on all above results.
Next, this is our main finding in these studies. Firstly, the UV result which shows the maximum wavelength for the complex. Due to the shifting from the graph, it shows that the complex has stronger ligand than H2O. Secondly, in IR, we know that nitrogen atom from the secondary NH group form an octahedral shape. After that, the electronic spectra, which shows the two bands of DD transition at lambda max. Next, in analysis with atomic absorption spectroscopy, that shows the content of nickel in the complex was 5.92 plus minus 0.05%. Thus, the formula of complex is as you can see here. For the analysis of electrical conductivity, the charge ratio K-ion and N-ion was 1:1 ratio. Lastly, for effective magnetic moment, the value was 2.99 plus minus 0.05 per magnetang. By simmering the nickel to nitrate hexahydrate and diphenylamine in methanol for 3 hours, the nickel 2 diphenylamine complex may be created. The complex formula has been obtained here, and the geometry structure is octahedral, and the UV maximum wavelength are at 724 nanometer and 396 nanometer.